we are covering Mohr's circle and combined loading, a critical topic in the Mechanics of Materials section for the FE Civil exam. This is a graphical method for analyzing the stress state at a point, and the exam will test your ability to construct the circle and interpret its key features. Let's start with constructing the circle. The horizontal axis is for normal stress sigma, and the vertical axis is for shear stress tau. A critical exam trap is the sign convention for shear. The NCEES reference handbook specifies that shear stresses forming a clockwise couple are plotted above the horizontal axis, and counterclockwise couples are plotted below. Tensile normal stress is positive to the right, and compressive is negative to the left. You'll be given a stress element with sigma x, sigma y, and tau xy. You will plot 2 points, the stress state on the x face, which is sigma x, tau xy, and the stress state on the y face, sigma y, negative tau xy. The line connecting these 2 points forms the diameter of Mohr's circle. The center of the circle, C, is found on the sigma axis at the average normal stress, sigma x plus sigma y divided by 2. The radius of the circle, r, is calculated using the formula r equals the square root of sigma x minus sigma y divided by 2 squared, plus tau xy squared. This radius is not just a geometric property, it is the maximum in-plane shear stress. The points where the circle intersects the horizontal normal stress axis represent the principal stresses sigma 1 and sigma 2. At these points, the shear stress is 0. You find them by taking the center, C, and adding and subtracting the radius, r. So, sigma 1 equals C plus r, and sigma 2 equals C minus r. These are the maximum and minimum normal stresses at that point. Another common exam question involves combined loading, where a structural member is subjected to multiple loads simultaneously, like an axial force and a bending moment. The key here is the principle of superposition. For a specific point on the cross-section, you calculate the stresses from each load type individually, and then add them algebraically. For instance, consider a point on the top surface of a beam under both axial tension P and a bending moment M. The total normal stress in the x direction, sigma x, would be P over A plus M times C over I. If there's also a transverse shear force, you'd calculate the shear stress tau xy using VQ over IT. Once you have these combined sigma x, sigma y, and tau xy values, you use them to construct Mohr's circle just as before. A frequent point of confusion is the relationship between angles on the physical element and on Mohr's circle. A rotation of angle theta on the element corresponds to a rotation of 2 theta on the circle, in the same direction. For a memorable shortcut, remember this phrase: the center is average, the radius is max shear. This directly links the 2 most important calculations to their physical meaning. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.